Good morning. Welcome to our live stream this morning on the MODULYS GP2, looking at the hot swap function of it. My name is David Heaton. I'm the sales manager for Socomec UPSs for the northern half of mainland Britain, and I'm joined today by Terry Meach, who is our senior technical support engineer.
Cheers. Hi. Yeah. So I'll be helping David out today with a demonstration on the MODULYS GP2, and also be keeping an eye on the chats all across the various platforms. So if you do have any questions, chuck them in there, and hopefully we'll try and answer a few at the end if we can. Cheers.
Right. So what we're going to do is we're going to look briefly at what we mean by modular, the benefits of a modular UPS, how we achieve high availability, which of course is a key thing with any UPS system, what we mean by hot swap. Both modular and hot swap are terms which are bandied about pretty readily in the UPS industry, and just want to try and put some definitions around those. Then we'll look at footprint and total cost of ownership, and then we'll wrap up with a quick summary and a Q&A session. So with the advent of modular UPSs, we needed to find a word for the previous generation of non-modular UPSs, and monolithic seems to have stuck certainly within Socomec, and that comes from the word monolith, which is a great big block of rock, and that's the way to think of it, a single entity. By contrast, a modular UPS is made up of multiple power modules in a frame, so instead of the big monolithic block of rock, it might be a pile of bricks, for example, and that's about as far as we want to go on that metaphor. But yeah, these multiple modules can be added to the system for scalability. They can be removed and redeployed if you need, and also we can put in additional modules above and beyond the actual power requirements to give us some redundancy. Different architectures with modular systems. So we've got here a monolithic system, rectifier, inverter, battery is not shown, and a bypass system, a single entity. Modular systems, a couple of different ones to look at here. This is one with a distributed bypass, so we're showing three different modules. Each one again has rectifier, inverter, but a little static bypass in each one also. And an alternative one, a more of a hybrid system where, again, the three modules with rectifier and inverter, but a system level central bypass and galvanic isolation for each of the modules. So we might use this very low power systems up to about 20 kVA, but generally we prefer on our medium and high power systems have a central bypass. Terry?
Yeah, the added benefit really there is from a maintenance point of view, is the central bypass allows us to carry out maintenance whilst the machine's still online and active and protecting the load, whereas with a monolithic system, standalone UPS, you have to go to bypass, so you are putting the load at risk whilst on raw main. So yeah, certainly an added bonus there of having a bypass in a modular system is always online.
Yeah, so exactly. So we don't actually need to switch to bypass to maintain one of the modules. But the other thing, the flip side of that, is the static switch itself is hot swappable. So Terry, do you want to show us how it works?
We've got the 200 kVA MODULYS here. We've got 3 power modules online and running, and we've got the bypass down at the bottom. There's only 2 screws which we've removed earlier, and it's just a simple case of pulling out. We can carry out maintenance, we can change and replace the fans if needed. All we get on the UPS itself is an alarm to say we've lost communication, but the system is actually still on our inverter. Go back to the main screen, we can still see we're online, and so we're still protected if there was a power cut. Coming back the other way, it's just a case of pushing the bypass back in. The alarms will eventually clear off, but again, we've stayed on inverter during that whole maintenance period, so there's no risk to the load at all.
Fantastic. Yeah, so even if there's a mains failure during that, it would carry on. So briefly, the benefits of a modular system. Availability. So availability is the proportion of time where power is provided to the load. Typically done, mentioned in the number of nines, so 6 nines, for example, would be 99.9999%. And it goes on longer numbers than that. And we get that from high MTBF, high mean time between failures, a low mean time to repair, and we'll look at those two in a moment. The benefit here is hot scalability. Again, we'll demonstrate that in a moment, but you can just pop a module in here, and it's as simple as that. Online maintenance, Terry's just mentioned that. You don't have to get your arms in the system to maintain it, and we can remain online while we're doing it. Total cost of ownership, we'll touch on that briefly at the end, but of course that's one of the key things. A design engineer's interested in the function of the system, but a lot of people who are paying for the system will be interested in the ownership over the years, cost of ownership. And we also have a very long-lasting design. We guarantee that we'll provide modules for our systems for 20 years after the first installation. So high availability. Availability is simply, I don't know if you can see that on the screen there, 1 minus mean time to repair divided by MTBF. So we need to drive down mean time to repair, drive up mean time between failures. So much easier to understand with a picture as ever. So we've got here a system. Blue is good, system is working. Yellow or orange is bad, system's not working. So in this example, if we've got just a single UPS with no redundancy, if there's an issue, we've got a failure, no power to the load. It's going to take time for an engineer to come to site, it's going to take time for him to repair it, and then we're back online again. So you've got that time where there's no power available. I don't want to sort of do too much of a downer on monolithic UPSs. That's certainly not the case here. They certainly have their place, and of course you can have redundancy with them by paralleling them up, and you would need 2 failures concurrently to get a failure here, but we're not talking about that in particular. We're illustrating the benefits of a modular UPS. With a modular UPS, if you have a redundant module, if there's a failure in one of those modules, the system stays up. There's no downtime. The time to repair that module is also extremely short. We're typically looking, if you have a spare module on site, looking at 5 minutes. Pick it up, 2 screws, pull the old one out, push a new one in, job done. So the modules themselves are self-sufficient and independent. The control of the system is shared between the modules, so there's not a single point of failure in terms of a control module. The display you see on the screen there is an interface. It's not actually the controller of the system. That can be swapped out and removed as well.
And as David mentioned there, the controls are all independent, so even if the main control board fail or any of the power supplies failed, the system still carries on running. The modules are intelligent. They've got their own software in them that says if this happens you carry on running no matter what. So like David said, the displays are all hot swappable, everything is hot swappable, absolutely everything, so the system always runs even in a really catastrophic failure, which is pretty unlikely. Yeah,
so it's a very robust design and it's a reliable build, which is what we want. We mentioned central bypasses earlier on. We at Socomec do prefer to have a central bypass, and the reason for that is in this system we've got 8 modules in a full system. In the early days of your deployment you might just have 1 or 2 modules fitted in the system. If you had a distributed bypass and there's a short circuit downstream, your little bypass switches are not really going to be rated for that full current, whereas you've got one rated for the full 200 kVA plus the fault current. It's much better chance of surviving a downstream event. So that's our view on that one. So increasing MTBF, I don't want to talk about this in any more depth here because there's a lot of complicated maths and big numbers which are kind of difficult to go through in this sort of forum. But we have got a couple of good white papers which I'd recommend. We can download them from our website, and after this webinar Sarah will email the link to you for those. But just 2 points about MTBF. The MTBF of a UPS system increases by an order of magnitude when you build in some redundancy, and as we'll see later, the cost of doing that with a modular system is much lower than with a monolithic system. And the second point is that the MTBF of our power modules is just over 1 million hours. It sounds like a suspiciously round number, but in practice that's what our design engineers worked out at the design stage. They then had that verified by university, but for the cynics among you, and I'd include myself as a cynic, the much more important thing is that in the 5 years we've been selling this thing, the field-proven MTBF is over 1 million hours. So we talked about MTBF, but the other part of availability is reducing the mean time to repair. And to do that, we've made everything hot swappable. So the cabinet itself doesn't have any active electronics in it. It's very quick to repair, and it's risk-free because we're doing it all online, as we mentioned earlier on. Hot swap, again, people saw it. Most modular UPS manufacturers will class their system as hot swap, hot plug, but we like to just put some definitions on that. So firstly, the system has to be live and online. That's what we mean by hot plug. You just plug it in. You don't need to switch to bypass, either internal bypass or maintenance bypass. There shouldn't need to be any special tools required. In our case, you just need a screwdriver. And we wouldn't expect any switching to be done either. Terry, do you want to just show what that look like?
Let's have a look. So you can see on the display we are still on inverter. So what I'm going to do is, assuming we're coming for, say, a maintenance visit, and we're going to take out one of the modules. So it's literally a case of taking off the front cover. There's 2 screws either side. I'll just pull the module out. I've had to do no commands to the display. I've had to do no switching anywhere else. I've just pulled the module out. Obviously, we would check that you've got enough redundancy, you know, check the load and make sure you can take one module out. Even if you were to pull all the modules out, the system would still go to bypass. So it is still a fail-safe in that sense. But once this is out, you can carry out maintenance. We can replace, you know, capacitors and fans and things. And going back in, it's just a case of pushing the module back in. It will then do some self-checks and then come back online completely automatically. The only alarms we get up on the display are just to say that we've lost communication with the module. So when the module's rebooting back up, those alarms will automatically clear. But again, we haven't had to do any switching. We're still on inverter. We've still got protected load going, you know, all the time whilst we're doing maintenance. In the case of just replacing that module, depending on the kind of maintenance you have, you could just take that module out, push a new one straight in and take that one off site and carry out a maintenance that way. So again, you're reducing that potential risk to pretty much nothing. You know, 5-minute maintenance at best, but yeah, zero downtime at all. Okay. So one more thing which merits its own slide and a gold star is something we're rather proud of, is that we've got a system whereby the firmware of a new module is automatically aligned to the firmware of a system. So it's very much plug and play, plug it in, and it goes. Now we're going to demonstrate that. You should be able to see a little bit on the display when it's necessary, but yeah. So this module, which we've left out on purpose, is a completely different firmware to the rest of the system. So as you can see, that other module's just come back on after its maintenance. So this one is a completely different firmware. It doesn't matter whether it's a higher firmware, newer than your system, or whether it's lower. You know, perhaps you've got a couple of sites where you've got different modules across them. So again, there's no tools required, there's no engineer required. You could ship this to a customer like yourselves, and all you've got to do is just push it in. As the system starts up, it carries out the same checks as all the other modules. So it will start up, and the first thing it's doing is it's checking its firmware. It's then seeing whether it's compatible, and it's doing that and checking and comparing with the controller. If the controller says you're of a different firmware, the module then realigns itself. So on the display here we can see it's carrying out an automatic firmware alignment. This takes around 4 to 5 minutes, so whilst that's doing, keep an eye on the bottom corner of your screen. You'll be able to see that whilst we carry on with the rest of the presentation.
Okay, yeah, it's this is a really key thing actually. We mentioned that it updates the firmware of the module. It aligns it with the system firmware. The reason we do that is because the system firmware, it's A, working, and B, it's what's been approved by the end user. So that's why we do it that way around. I did have a nice experience with this once in a previous job where we were demonstrating our first new modular system which we'd got into the office, and we had a key customer there, and we really should have tried it first, but what happened was we plugged in the new module, said look, this is how easy it is, we plugged it in, it took a couple minutes to do all its tests, and at the end of that time there was a big red light which came up and it said firmware incompatibility. And that was the end of the demonstration. It then needs an engineer to come in, plug in his laptop, upgrade the firmware manually, which rather defeats the object of a user being able to do it. So actually, when this was developed, when we were being given the presentation by the development team in Italy, they showed the development costs, and it was interesting that the firmware costs were similar to the hardware costs. So yeah, how are we doing there, Terry? Is it still?
Yeah, so we've done the booster, so there's separate firmware for the booster, rectifier side, and then now we're on to inverter. So again, we haven't had to do anything, we're a couple of minutes through, so
okay.
Yeah.
We'll just do a quick talk about some of the bits and pieces on the system. So you've seen the real thing there, but just to reiterate, the cabinet itself has no active electronics in it, so that's an important thing from an aging point of view. Electrolytic capacitors, things like that age, so if they're not in there, that's not really a problem, it's just connectors. We've got the MMIC panel, which can be completely hot swapped. We upgraded that a couple of years ago from a monochrome one to a colour one, and again, they can just be hot swapped in the field. Power modules we've talked about, static bypass we've talked about. There's some slots for the communications, so your Ethernet connections, your relay alarms, things like that, they can be swapped out. And also there's some service parts, there's some power supplies.
Yeah, so I mentioned earlier we've got power supplies, but if you can just about see, there are two power supplies with the system, and they are redundant. So even if you come to replace them after, say, 10 years, you can do them independently, you could change one at a time. In fact, you could pull all the power supply fuses out, and as I mentioned, the software built into the system carries on running, it doesn't matter. So we can do a controller replacement, power supply replacement, the display, and absolutely everything can be done whilst the system's still on inverter and your load is protected. So it's really good.
Good, okay. We've also got the same modules in a smaller system. So this is 200 kilowatts. We have smaller systems and larger systems as well, but using the same modules, we have another two types here, which might be of interest if you don't need the full 200 kilowatts. We've got a small one here, which has two modules, so it can be either run as 50 kilowatts total or 25 kilowatts N+1, and it's the whole package: modules, power slots, and static bypass. And then there's one here which has 4 slots, so it's only rated at 75 kilowatts, the static switch being the limiting factor there, so 75 kilowatts N+1. And again, in both of these, the controller is shown hidden away there.
And the modules themselves are exactly the same as the modules here. The only difference is that front grille, but otherwise they are completely compatible. So just pull you back to the display. As you can see, the module's completely finished its firmware update. So the firmware's done, and we just got a notification to say the system was expecting 3 modules. It's now seen that we've got a 4th module. It's now asking us, do we want that for extra redundancy or do we want it for extra power? So again, you can set all this from the display, so we just accept that alarm. We get the wrong configuration because, as I mentioned, it's expecting 3 and we've got 4. So we'll come into service, going to go UPS settings and redundancy. You see we've got 3 modules. I'm going to set that for 3 and 1 redundant, accept that, and after a few moments that's going to all clear, and we just installed a module within 5 minutes, no engineer required to come to site. We've now got a bigger system with extra redundancy.
Yeah, it's really good. And just to reiterate, although there's been excuse me, a bit of a Christmas tree of alarms there are alarms happening because there is an event, something has been changed, but the load is protected, double conversion online throughout.
Yeah, we stayed on inverter during that whole process. We've had to do no switching. We expect a few alarms when we're doing something, and we'd hope to see them. So yeah.
Yes. Yeah. Footprint briefly. A modular system like this, one of the big benefits of it from a cost point of view and a space point of view, footprint point of view, is that your redundant module, your redundant part, is just one little 25 kilowatt module. If you're using monolithic systems, then you're going to need 2 cabinets. You might go for 3 cabinets. So here, if it's 175 kilowatts N+1, depending on what your load is, you might use a couple of 160s or a couple of 200 kVA systems. So here you've got 25 kilowatts of redundant power, here you've got 200. It's a lot of extra cost. The batteries similarly will be more on that sort of system. You might choose to make your redundant power a bit lower, so you might have a couple of 80s, or 3 80s or 3 100s, so your cost of redundant power is less. It's an important thing. A modular system without redundancy is going to be more expensive than a monolithic system. As soon as you bring in redundancy, it immediately pays for itself. Yeah, my mind went blank on the second point on that one, but never mind. Scalability is a big factor as well. So in terms of total cost of ownership, the slightly tacky phrase pay as you grow is applicable here. So we've got a system here. These are 25 kilowatt lines. So this black line at the bottom here is our load, growing, decreasing briefly over time. And we're trying to follow that with our UPSs. As the capacity requirements increase, we can add in 25 kilowatt blocks. So you can see here that we're following the black line fairly closely. If we're using 100 kVA systems, you put in 100 here, and suddenly you have to step up a big amount more. And that blue shaded area there, between the yellow and the blue lines, that's the capacity you've paid for, which we're not using. With our modular systems, especially because of this firmware realignment thing, if you want to just take a module from one building, put it in a UPS and another one, you can easily do that without risk of it not being compatible. I think we mentioned this already. Low cost of redundancy. Efficiency is very important. I think we've got time briefly to mention our
the energy saver. So like, as you said, as you're changing up and down with that load, you know, instead of, let's say you've only got the one system, you don't want to take a module out and leave it, you kind of want to rotate them. The system has a built-in energy saver feature, and again, you can set this from the display, just within the controls. It's a mode of operation, so we just select energy saver and switch it on. And then what this will do is all automatically, you know, once you've said I want so many, you know, redundant modules, or this is what size power I've got, it will say, right, how many modules can I switch off? And it will just rotate them as and when, you know, the loads go up and down. And again, with energy saver, if any alarm event occurs, so if we go on to batteries and there's a mains failure, it switches all the modules on straight away. So as you can see, we put it into energy saver within a few seconds. The bottom module here has gone offline. So we can now still, we've got two modules that are online for the system and one for redundancy. They're all on, they're all working, but it maintains that redundancy level based on what you've set and the applicable load at the time. Yeah.
So using a smaller number of modules moves them into the higher efficiency area of the curve. So the curve on efficiency sort of starts really quite low at very low powers and gets much better as you get up to sort of 25-30%. So it allows a couple of modules or a smaller number of modules to operate in a more efficient mode. We demonstrate this in the factory. Actually, we've got three of these together, giving a 600 kilowatt system. We set it to, I don't know, about sort of 50 kilowatts of load, and in energy saver mode, all the modules bar 4 turn off, and then we just hit it with the full 600 kilowatt load, which if you're an old engineer, you sort of wince a little bit, but actually it's fine and the output is not perturbed at all, which is quite impressive. Okay, so just to sum up, and then we'll go to some Q&As. Benefits of a modular system: maximum availability, that's a function of the modular concept generally. High MTBF, low MTTR, and I hope we've demonstrated both of those a little bit today. Scalability, very important. Online maintenance, yeah, that's a bit of a hidden cost up front. It's more of an OPEX cost rather than a CAPEX cost, but it's equally valid to the bean counters. Total cost of ownership, very, very important, again, to the bean counters. And a long-lasting design. So we've got these systems, we're going to actually provide modules for 20 years to come. So, have there been any questions?
Yeah, let's have a look. We've got, I like this one about airflow. Somebody's asking, like, obviously the airflow and setting up. So from a servicing point of view, everything is front access, and the same for the airflow. The airflow goes in through the front and then out the back. So you do need a small amount of space, about 400 mil at the back of the machines. And there are options for top entry.
There's an option at the back for a top exhaust. So it's I think 200 mil. So instead of needing 400, you only need 200, and that it's a chimney up the back with exhaust fans on the top.
A couple of fans on top as well. But so then you can push it right back and regain that space as well. Something about firmware updating, so a firmware updating for the whole system. So yes, obviously the firmware that's held on the control board that obviously does the auto firmware alignment. If you did need to firmware update the whole system, you would need a Socomec engineer to do that. but again, we can do that whilst it's all online. So again, as long as you've got redundancy, you've got an extra module, we will take one module off at a time. It does the firmware update, puts that one back online. Once it's happy, does the next one, and then it will do the bypass, control and display. So yeah, you don't have to actually go to bypass even for doing a maintenance firmware update that way, which is superb. And another one on battery options, so different types of battery. So here we've only got internal batteries because we're limited on space, but again, with any battery setup, we want to make sure, you know, a modular UPS system's only as good as its modular battery. So here we've got internal batteries. We've got a string per tray, and as you can see, you can have batteries in any of these. We put them at the bottom just to save the heavy lifting, but we could have batteries at the top or modules all the way through. You could have external batteries, but the key for me is making sure that you've got a modular system. So we could open one set of batteries up, carry out maintenance on those batteries, change them, replace them, do impedance testing, stick them back online. We're still on inverter. We haven't had to put the load at risk.
It's still got battery protection of
And
the
we've still
remaining
got
ones.
battery,
Short
yeah.
of time, but it's there still.
So these are lead acid batteries, and we've got lithium ion options as well.
So it's lithium ion ready. We've supplied systems with lithium ion batteries, so if you need that, they're available also.
Yeah, I think that's pretty good in terms of question front. If you do have any others that you think of later, do drop them in, and we'll try and get you answers to them as soon as we can.
Okay, well, thank you very much for joining us this morning. That's been good, and I recognised a few names on the list of people who'd signed up, so yeah, nice to see you guys, and welcome. We'll see you again.
Yeah, thank you, and we'll send out the white paper via email, and yeah, we'll see you on the next one. Cheers.
Bye-bye.